Hi guys, today we're going to be going over lesson 31-2, the axis of symmetry and the vertex. Our learning targets: identify the axis of symmetry of a graph of a quadratic function, identify the vertex of the graph of a quadratic function. The axis of symmetry of the parabola determined by the function y equals ax squared plus bx plus c is the vertical line that passes through the vertex. The equation for the axis of symmetry is x equals negative b divided by 2a. The vertex is on the axis of symmetry. Therefore, the x-coordinate of the vertex is negative b over 2a. Each point on a quadratic graph will have a mirror image point with the same y-coordinate that is equidistant from the axis of symmetry. For example, the point 0, 5 is reflected over the axis of symmetry to the point 6, 5 on the graph. Item 1. Give the coordinates of two additional points that are reflections over the axis of symmetry in the graph above. We have this point right here, for example, which is 1 away from the axis of symmetry. So there's another corresponding point that's 1 away over here. And so when we write down those points, we're going to have, say, the point x is 2, y is negative 3, and the point x is 4, y is negative 3. Notice the y values are going to be the same, and the x values are going to be different. But what's really interesting is that the axis of symmetry is going to be halfway between, or a simple average. We can average these two numbers. So 2 plus 4 is 6. 6 divided by 2 is 3. And you'll notice the axis of symmetry is right there on 3. Item 2. For each function, identify the zeros graphically. Confirm your answer by setting the function equal to 0 and solving by factoring. All right, so what we're going to do is we're going to both draw the graphs and find what the zeros are by factoring. So I'll start off by finding what the zeros are by factoring. And I may just let you guys graph them on your own. So to find out what the zeros are by graphing, you got to remember we're looking for x-intercepts, and that's when y is equal to 0. So it's going to be 0, y is equal to 0, and we have x squared plus 2x minus 8. So that's where we get y is set to be equal to 0. And so now we're just going to go ahead and factor this. And so we have our x and our x, and then our back sign tells me the signs are different. The front sign tells me that the larger of the two factors is going to be positive. I'm looking for factors of 8, that when you subtract them, they become 2. So of course it's 4 and 2, and since the larger one's got to be positive, 4 is positive, the 2 is negative. Now we go ahead and find the zeros. We set each of these equal to 0. So x plus 4 equals 0. That's going to give me x is equal to negative 4. And x minus 2 is equal to 0, which will give me x is equal to 2. So my zeros on here are negative 4 and positive 2. All right, so the next one, we're going to go ahead and put y is equal to 0, so it's going to be negative x squared plus 4x plus 5. And we're going to go ahead and work this out. But notice we have a negative value right here. So what we're going to do is we're going to factor out a negative 1. And what that's going to leave me with is we're going to change the sign of all these numbers. So it's going to be x squared minus 4x minus 5. And then we're going to leave the negative 1 as one of our factors. And then we're going to go ahead and factor this out. So it's going to be an x and an x to make our x squared. And then the back sign tells me the signs are different. And the front sign tells me that the larger of the two factors is going to be negative. So I'm looking for factors of 5. When I subtract them, I get 4. So 5 and 1, 5 minus 1 is 4. And the larger one has to be the negative, so that's going to be the 5. That's going to be the 1. Now when I'm trying to figure out, well, what are the zeros? Well, I don't need to do anything with this negative 1. We don't even need that anymore. All we have to do is figure out what values of x will make this whole thing equal to 0. And so if I can make this equal to 0, the whole thing is 0. Like make this equal to 0, the whole thing's 0. Don't need to worry about that one. So I'm going to go ahead and do that. So x plus 1 equals 0. And so that means x has to be equal to negative 1. And x minus 5 equals 0. So x would be positive 5. Item 3. For each graph in item 2, determine the x-coordinate of the vertex by finding the x-coordinate exactly in the middle of the two zeros. Confirm your answer by calculating the value of negative b over 2a. So the first thing I'm going to do is I'm going to identify the zeros in negative 4 and positive 2. Okay, those are my zeros. And so to find the value exactly in the middle, I simply average these two. So it's going to be negative 4 plus 2 equals, and that's negative 4 plus 2 is negative 2. And then to find the average, I'm simply going to take that number that I get there and divide it by 2. So negative 2 over 2 is equal to negative 1. Now it says to confirm that by using the formula for the x value of the vertex. And so I'm going to do that. That's going to be, we're going to have a, b, and c, just a reminder. And so a is, of course, the coefficient of x squared, which is 1. B is the coefficient of x, which is 2. And c is the constant term, negative 8. So I'm just going to go ahead and fill this in. That's going to be negative, and then 2 over 2 times 1. So that's going to be negative 2 over 2, which of course is negative 1. And these match up, they confirm. So let's go ahead and do B. So B, we found the zeros to be x equals negative 1 and x is equal to 5. And so when we look for the difference, it's negative 1 plus 5. Negative 1 plus 5, which is equal to 4. And then we're going to go ahead and divide that 4 by 2. Okay. I wrote it a little bit different this way. 4 divided by 2 is just 2. So let's confirm it using the formula. So in this case, A is negative 1, B is equal to 4, and C is equal to 5. Now we're going to use the formula to verify this, and the formula is negative B over 2 times A. And so we're going to plug in the B value, which is negative, which is a 4, and then 2 times the A value, which is negative 1. And so we're going to end up with a negative over a negative, which is positive. So it's going to be positive 4 over 2, which is equal to 2. So 2 should be the halfway point. It does match up with what we got over here. Item 4. For each graph in item 2, determine the y-coordinate of the vertex from the graph. Confirm your answer by evaluating the function at x equals negative b over 2a. Okay, so I didn't do the graph. There's another way of doing that. If we know what the x value of the vertex is, we could just plug it into the equation and come up with the y value. So we're looking at the graph and the graphs in item 2 for the first equation, the same one we've been working with, and we determined that the vertex was at negative 1. So the vertex is at negative 1 and some y value. We don't know what it is. Well, all we need to do to find the y value is plug it into here. So we have y is equal to negative 1 squared plus 2 times negative 1 minus 8. So negative 1 squared is 1. 2 times negative 1 is negative 2. And then we have minus 8. And we work from left to right. 1 times negative 2 is negative 1. Negative 1 minus 8 is equal to negative 9. And so the y value should be at negative 9. So the vertex then is at the point negative 1, negative 9. And we can do the same thing with the second one. So on the second one, the vertex was at 2. The vertex was at 2. So what we know coming into this, without having to worry about a graph, is the vertex, the x value of the vertex is 2, because the axis of symmetry is at x is equal to 2. So we go ahead and plug that in. So we have y is equal to negative 2 squared plus 4 times 2 plus 5. Now, pay attention to what I did here in the when I plugged in the 2 there. The negative is outside of it. And so we're going to go ahead and just do the work. 2 squared is 4, and then we have the negative, so it's negative 4, plus 4 times 2, which is 8, plus 5. And then, of course, negative 4 plus 8 is going to be positive 4 plus 5, so that one's going to be a positive 9. So that one's going to be a positive 9. So the vertex is at the point 2, 9. Item 5, reason quantitatively. For each graph in item 2, determine the maximum and minimum value of the function. And again, I haven't been drawing the graphs, so the idea here is you can see that you can do everything with just the numbers. Remember, the minimum and the maximum is going to be the y value of your vertex. And so as we're looking at this, we're trying to determine, well, what's it going to be? Well, I can start off by looking at the a value of these equations. The a value of these equations. So that one's positive, so that means it is a happy flower. So that's going to have a minimum. And this one is a negative, so it's a sad flower, so it's going to have a maximum. Okay? And so now we just look at the vertex, it's the y value. So for the first one, it's going to have a minimum of negative 9. And this one's going to have a maximum of positive 9. Check your understanding. For the function y equals negative x squared plus x plus 6, use the value of negative b over 2a to respond to the following. Identify the vertex of the graph. Okay, so in order to find the vertex, we have to first find what the x value of the vertex is, and then plug the x value into the equation to find the y value. The equation given will give us the x value of the vertex. So we simply identify, first of all, a, b, and c, where a is negative 1, b is positive 1, and c is 6. Okay, we're not using c, but we still want to get used to doing that. So we're going to plug it into our formula. So it's going to be negative, and then it's going to be 1 over 2 times negative 1. And again, notice right off I have a negative on the top and a negative on the bottom. That's my answer is going to be positive. It's going to be 1 over 2. Okay, 1/2. Okay, so that's my x value. So when we talk about my vertex, it's going to be at the point 1/2. It's the x value, and so I need to find the y value. So I'm just going to simply plug it into the equation. So we have y is equal to negative 1 over 2 squared plus 1/2 plus 6. And you could just put that in your calculator if you want, but we're going to go ahead and do the work. So 1 over 2 squared is 1/4. So it's going to be negative 1/4 plus 1/2 plus 6. And so negative 4 plus 1/2 is positive 1/4. And then plus 6 is going to be 6 1/4. 6 1/4, or 25 fourths. My answer is 25 fourths. Or you could write this out as a decimal if you wanted to, as 0.5 and 6.25. Item 7, write the equation of the axis of symmetry. Well, that's easy. It's just the x value. So the equation of the axis of symmetry is going to be x equals 0.5. Okay, and I'm going to go ahead and leave the 31-2 practice problems for you to do as homework. If you have any questions, please come to tutoring weekdays at 3 o'clock on Zoom.